Welcome everybody to Let's Play Mathematically, Play to Learn, Play, Think and Learn. It's about, guess what, playing with maths and learning all at the same time. You can buy the book, the link is in the description, and you can download just the PDF, which costs less, and you can also free, whether you buy the book or do the PDF, you can go to the Aiming High website through the link on the publisher's website and get all the resources that you need to play the game. You can print them out, draw them out, enjoy. Tony is the author of the book and your usual host. She's the founder of AIMSSEC, and I am the founder of Bubbly Maths, and my purpose in life is that every child on earth will love learning and enjoy mathematics. What better way than to work with teachers with amazing resources that Tony creates? Cynthia.
Yes, so I'm Cynthia and I'm a retired maths teacher who at the moment enjoys playing myself with all sorts of maths games. Also I do teach teachers in South Africa.
The games that we're playing are going to help with playing systematically, visualizations, place value, number sense, strategy. Got a lot of probability coming up, and of course drill and practice with arithmetic, working with vectors, and we use the spiral learning concept. Now, unlike usual, where we start with the young learners and work our way up, every single game, I'm pretty sure every single game can be played in some version with young learners, and there are resources to follow up. So here we go. Boom. All the age groups and every single game that we're playing today, you can work out a way of playing it with all different ages, and there are backup resources available to you to help you do that.
We're asking you to join in with us. There's no point in just sitting and watching us play. So we are going to play and demonstrate some of the games, but you will understand them much better and get to appreciate how you can adjust them for your classrooms if you actually do them with us. So we're asking you to have a pencil and paper handy. So I hope if you haven't already got such things that you can very, very quickly lay your hands on some scrap paper and something to write with. Yeah, so we're advertising this as play to learn. And that is the whole theme of the book. But, you might say, well, why? Why, as teachers, why we're not teaching? This says we're going to be playing. Because play basically is something that comes naturally to all children. From very tiny babies, you'll find they love to play. It's a natural thing. It's something that they're happy to do. It's not frightening you. Most children, say, there are obviously some exceptions, but most children love to play, particularly with other children and also with their family, with their parents. And while they're doing this, what are they actually doing? Why are they playing? Well, what they're doing is they're rehearsing, right? They're getting ready. They're practicing skills that they will need for life in a very safe family or school environment or friendship group environment. So they're practicing all sorts of skills. The biggest one that I look at when I see this poster is, I think, is the social skills. They're learning to be with other people, right? And in a game situation, they're often learning to share. They're possibly learning to take turns. They're learning to listen to each other. They're learning to express themselves, because their friends will soon tell them if they don't understand what they're saying. So they're learning how to get along with other people in a fairly safe and controlled environment. And while they're listening, they have to listen with respect. They'll soon, obviously they do sometimes get aggressive, but if someone says, grab something, another child will soon say, no, that's mine, or they'll soon sort of look after each other and learn from each other. And so that's the sort of early years. But then when they go through the school, they learn by playing games, thinking skills, reasoning, how to explain it so someone else can understand. then if it's not going their way, if perhaps what their first strategy they're thinking of doesn't work, they have to be flexible and think of another way that might work. So these are all skills that they learn, both social skills and thinking skills, that will bring the rewards later in life, the sort of skills that employers are looking for. They say things like you must have resilience or flexibility in the workplace. And these are all skills that they can learn through play.
Straight into the
Yes.
first game.
Yes.
I'll leave those instructions on the board. We're not going to show you the instructions for the other games because I'll have my visualizer on. We want you to draw a grid, a 5x5 grid as shown there. So if you haven't already drawn it, please draw a 5x5 grid and draw in 25 numbers between 1 and 100.
Perhaps I should jump in and say here that Caroline's going to be spinning numbers from 1 to 10. So before you put your numbers in, think which numbers are sensible. She hasn't told you she's going to be spinning a spinner twice. So you'll have two numbers between 1 and 10, and you can do any mathematical operation with them. You can add them, subtract them, multiply or divide. So before you put your random numbers in, you might want to think which ones would be useful.
As Cynthia says, they have to be possible. The winner, by the way, will be the first person that can make a line of 5 on your grid. So you definitely have to make sure the numbers are possible. So
depending on how much time we have, we might stop at 3, but we'll see how we go. Oh, the other thing to say is that you can fill in as many that you can make with those two numbers. You're not restricted to just not crossing in one number. If if you could make 3 or 4 different answers with your two numbers that you get from the spinner, then you can cross them all off on your grid. So this is we're playing bingo, but with bingo you normally only cross one number off at a time. We can cross as many as we can make with our numbers.
And we're going to add them, divide them, multiply and subtract.
Okay.
And we're going to subtract the larger number from the smaller number. And the other thing is you must use each number only once.
Oh, yes. No duplicates allowed.
I knew there was something I hadn't said.
Yes.
Okay. So I'm nearly there. I was about to make a duplicate there. For some reason, I love the number 25 and I just keep wanting to write it, but I've already written it once.
The other thing is that you can't change your mind as you go along. No cheating allowed.
Sure no cheating. We're not really yeah, you can't just fill in the numbers that we come up with. Go, yay! I've got 5 in the line.
No, definitely.
Normally, you'd do this with your class. I'm going to record all the answers. And here we have my spinner, which is something that there are instructions on the Aiming High. All this is a paper clip. And I've actually got a little screw there, which is quite fun. And I'm going to spin it. We have a 6. A 6 and 10. The first two numbers are 6 and 10. And Cynthia and I will just show you, we're going to add them. So we've got 16, subtract them. So we've got 4, multiply them. So we've got 60 and divide them. We're only going to go, you can play multiple ways. You can use decimals if you want. We are sticking with whole numbers and we can't get a whole number by dividing 10 divided by 6. Also, we're going, we stay basically whole numbers. So that's not possible. So we've got 16, 4, and well, I may as well. There's no reason why you shouldn't see my board now because we've all filled in our boards. So I've got 10. I know I've got 10.
No, Caroline. Oh. Caroline, 10 is a number, not what you get when you add.
Oh, no.
No, you can only, it's good. At least we know, we can tell the teachers, you can only cross off.
I know that.
16, 4, or 60. So if you've got 16, 4, or 60, and I've got 16 and 4 on mine, so I've already crossed over 2.
16, 4 and 60. So I knew I had one of the numbers. That's why I went straight for the 10. It's a 60 that I've got. So I've still got 10. I've still got to get 10. So I'm here to demonstrate all the mistakes that your learners will make. And we're going to have an 8.
8, right.
And we have a 6.
Okay.
So 8
What?
plus. Go ahead, Cynthia.
Yeah, sorry. So 8 plus 6 is 14. I was just thinking, what can we get? Yeah, subtraction. 2, I think. Yes. Multiply 6 8s are 48. So just to reiterate, Caroline, you may only cross off 14, 2, or 48.
It's a really valuable conversation. Is that divisible? Can you divide 6 by 8 and get a whole number? That have found that to be a very valuable conversation. So I'm looking for 14, 2, and 48.
14. I've got 14 and 2, but I haven't got 48. No.
No 14, no 2. I've got 48. So I've got 2 crossed out. I've got to remember that's not crossed out. All right, here we go. And again. 3. 3. All right, nice square number. So we have
3 and 3.
6, 0.
So
we're only playing from 1 to 100.
Yep.
But actually, we could have included 0 there, couldn't we?
Might have
and 9 and
1.
1. So 6, 0, 9, and 1.
So 6.
I've got 1.
Yes, I've got 1.
And it's also where to place the numbers as well.
Yes.
Well, did we have 2? We had 2. I have 2. I didn't cross it out. Oh, I've got 2 there. That's not 1.
3. You've got what? Bottom right. Bottom right.
No, but what 3. I mean is I've got 2 and a
diagonal.
So if I can get 25 and 10, and I've got a line going there as well. Okay.
I've got 3 in a row twice as well. I've got two lots of 3s in a row, but I haven't yet made 5. So
okay. Okay, here we go. Whoops, that wasn't a proper one. 10. And don't cross out the 10, Caroline.
No.
4.
Unless you get a 1.
So
add. Oh, we've had 14 before, so that should
14, 6, and 40. And is 10 divisible by 4?
No. So what numbers may we cross out?
14, 6, and 40.
Well, 14, I say we've had before. 6 and 40. Oh, I've got 40. Oh, and 6 we've had before, haven't we? Have we?
Have we?
Yes.
Yes.
We've had 6 before.
Whoa,
yeah.
We've had 6. Oh, twice, not 3 times.
Yeah.
But yeah, it's
and
interesting.
14 twice, which is something we need to think about later, won't we, when we analyze this?
Yeah. 9. 8.
Oh, heavens.
So we have 17. 1. Is that the first time we've had 1?
No, we've had it before.
Oh yes, we had it with the division. And
so 72.
72. And the division doesn't work. So 17, 1, and 72. I've got 17.
Yes,
One's
I've
already
got
gone. And I've got 72. I've nearly got 509 over here.
Yes, I'm only missing. I need 5 to turn up. I've got to make my 4 or 3.
5.
I want a 1. 1. Get a 1.
That's not a 1.
No. 5 and 9. Yeah.
So we can create up to 4 answers with our 4 numbers to cross out every time we do it. So 5 plus 9, 9 minus 5. You can vary this. You can make it more complicated. You can do only adding. You can do whatever you want to do in your classes. 945, and then it's not divisible. 4, 14, 45.
That's interesting. We've had 4 and 14 before.
Yes, that is.
No, 5.
14, 45. No. So here we go. 2. It was on 4. It slipped down because I've got something here. It was on 4. So we have 6, which we've had before.
Yes. 2,
2, which we've had before.
Yes.
8, we haven't had before.
Oh, division. Oh, another 2.
2, another 2. Getting lots of 2s.
8. Was it
2,
2, 6,
2,
and
6.
8? Was it?
2, 6, 8. Who do we appreciate? Nearly.
Oh, yeah, not quite. No, I've got an 8.
No,
2
none
we've
of I
had,
don't
and
have
6.
comment if you've crossed out 5 in a line. We're looking for 5 in a line, 5 vertical, 5 horizontal, or 5 diagonal. I'm only missing 2. Ignore that for those that weren't here. That was me doing doing what your learners might do. I'm showing good example. I was being a 9 and 8. We've had 9 and 8.
Yeah.
So we don't need to do that one again because we've done it. 9 and 3.
Oh, I'm gonna win. I'm gonna win.
Oh no.
9.
9 plus 3, 9 minus 3, 6 again. 9 times 3 and 9 divided by 3. Okay, so we've got 12, 6, 27 and 3. 12, 6, 20. I'm sure I wrote 27 and 3. So I've got a whole cluster here, but I still don't have 5 in a line. Have you got 5 in a line, Cynthia?
Yes, I have 5 in a line. Yes, the 3 was what I was waiting for. I was waiting for a 3.
As anybody
or
else?
a 5. These are my diagonals, so I've got those.
I suspect Cynthia might have done some analysis before we started.
Because I'm uber competitive, as most people know.
We have heard this.
It's been rumored.
This.
It's been rumored. Yes.
So, while I
anybody...
prepare for the next bit, over to you.
Yes, so as Caroline said, I do like to think about games. I do love playing puzzles and games. And so I wanted to know which numbers should I put on my grid? Which numbers are more likely to turn up than others? Yeah. And it's very important that you do think about this. And well, it's not important when you play it the first time. You know, you can play it with your class or with your children, how you like, and see how often or how long it takes for you to get 5 in a row, and then to realize that sometimes some numbers you might have put down don't turn up. So I looked at it more from the angle of which numbers turn up more often. But when Caroline was thinking about it, she was trying to work out which numbers never turn up. So between our both angles, I think you can do quite a bit of analysis with your learners. So which numbers don't turn up? Obviously, we've only got the 2 digits. We've got two digits between 1 and 9. So when we add, the biggest numbers we can add is 9 and 10. And when we multiply, yes, the biggest number we can get 100, but there are lots of others in between which we can't get. And one of the sort of first things that you can find is that you can't make prime numbers bigger than 19. And you can do quite a little bit of work on that. And there's a lot to do with prime numbers in here. Which types of prime numbers or multiples of prime numbers can't you make? I went the other way around. I wanted to know which numbers turn up more often, because I thought if I put the numbers down that turn up more often, I'm more likely to win. And that's way I tackled this. So you can look at your times table grid. You can analyze, a basic 10 by 10 times table grid, and you can soon count up how many times a particular number will turn up. I mean, I just did 1 to 20. I wrote down all the numbers from 1 to 20 and then tallied them, how many times they turned up on a 10 by 10 multiplication grid. You can also set yourself a 10 by 10 grid and fill in the answers when you add. You could do the same thing with subtraction. Do your grid with your 10 numbers across, your 10 numbers down that you're allowed, and write in the space, you know, do your sample space and write in all the answers when you do a subtraction. And that way you can see all the different numbers that will turn up and get a feel for which ones you should put on your grid. So that was what I was playing at. And to say, you can make that as intense or as easy or as flippant as you like with your class, but it's a nice idea to get them to think, was it sensible to put down, I don't know, put down 23? Yeah, was 23 a good number to put in your grid? You might like it. It might be the day of the month you were born or something, but it's not going to help you win the game.
The way you play it, first of all, because when you have got a little bit more time with your learners, when you're teaching them the game, just let them put in any number at all, and they will soon find out that they're not getting any of their numbers, and then they can start wondering why. They're much more engaged in the process if they're frustrated because none of their numbers are coming up. And I really like the idea of creating a poster, and this again wouldn't be just a one day, one moment activity. Over time, fill in, be really systematic and thorough with your poster. Have we got all the possible answers? How many times does each number occur? And that way they can not only make sure they put the right numbers in their bingo grid, they also can be strategic about the positioning of the numbers. Like, I was a little bit sneaky. I actually put 1 in the center because I kind of knew that was the most likely number. And the thing is, this is the what your learners can discover.
Yeah, but Caroline, if you go back to if you look at what the answers that turned up, it was quite surprising. We had, was it 14 turned up quite a few times? I mean, there were some numbers there that you might not expect because we were spinning. So this is also, we're bringing in a bit of probability that, yes, with all the analysis in the world, will tell you that 1 and 2 are most likely to turn up more than anything else. But, you know, it's probability. So when you spin, any number is just as likely to turn, any number from 1 to 9 is as likely to turn up as any other number. So, you know, you've got to bear that in mind. It's not a certainty that you will get all your numbers that you expect.
Absolutely. And we only got 1 twice.
Yes. Yes, so we got other numbers more often than 1, whereas 1 is theoretically the one which should turn up more often. So that is just another example of experiencing probability. You don't always get what's in theory you should, what in theory you think might turn up. So we've got lots of sort of dice, and so I see more dice turning up here now. So you're
Yes, indeed. Just making sure that you can see the whole board. Oh no, we don't need the whole board because we're only going up to 50 because of time. So we're going to go, normally the game play all the way to 100, and you can play it to the moon and back. So you can go to 100. So you're adding, you're going to throw 2 dice. You've got your markers, and you add them together and just move along. Now, it's a game of pig, which means that it's, again, probabilities involved. If you throw a 1, now you can play this on a piece of paper, and I'll do that in parallel with this. We'll play it on the board, and I'll also keep tally so you can see how it's done on a piece of paper. But if ever you throw a 1, that's the end of that go. So you go back to the beginning of that go. But if you throw a double 1, you go back to the start, the very beginning, go back to 0. So we're only going to go to 50, and we're going to play to the moon and back. But if you're playing the game normally, you need to get to exactly 100 for coming to here. You need to get to exactly 100. So even the strategy so if you end a game here, you'll see you have to decide when to stop throwing the dice. When you feel it's you're in a safe place, or it's not worth taking the risk of throwing again and losing your position. Now, I'm just going to make this so that I can keep track of the score for you. And so I'm going to tally it, and we're going to play the game as well as me tallying it. So Cynthia is blue and I am red. Well, I say red, and I'm saying this, actually, I've just kind of gone in there because we were hoping that we'd get everyone chipping in here. So what we'd love you to do, you're with me, Team Red, is say when to stop. We're just going to start it off. And Cynthia, you go first because you've got the nice color. Sometimes you can have the younger child go first. This is a good game to play one. You can play one against the whole class, or you can have your learners play it just against each other on the people that are next to each other. Right, I'm going to throw. You throw your own normally, but that's not possible here.
Okay, 8 for me then, yes. So
8 for Cynthia. So are you going to continue or
yes,
stop?
please.
So I've got Cynthia is got an 8. You're going to continue. If you throw, okay. 6. 1, 2, 3, 4, 5, 6. So you don't need to use this board. This board is better for younger learners or for your inclusion for your lower attainers. So we've got 8 plus 6. So Cynthia's at 14. Again?
Yes, please.
Risking
yes.
it? Oh,
I'm risking it. Yes.
You got to think about. You've
No,
got to think about
no.
when you should stop. And
Right,
in the
okay.
inclusion guide that goes with this game, there's lots to read about when it's wise to stop, like strategy wise. And so it's my turn.
Yeah.
So Cynthia is actually back to 0.
So you cross me out
because we're back to 0. Only because she's at the beginning. Oh, well, I don't even get a go. So nobody could you don't even bother to put anything in the chat. Don't even get a go because we threw a 1. Cynthia.
Okay, so what's that? 9. Yes.
Are you going again?
Oh yes, that's only one go. I can't. Got to keep building up. 6.
1, 2, 3, 4, 5, 6.
Yes, I'll chance my 3. Yes, try again.
Oh my goodness. Ah! Right, let's see if I didn't even record you.
No, I'm back to 0. No, it's your turn. It's your turn. I threw a 1.
Right. Yes, you did. I've got Cynthia there, and I'm the team. I'm going to say T for team. We're together in this. So you know what we're going to do? We're going to go to 8. We're stopping. Nobody's commenting, so I'm going to say we're stopping because we're ahead of Cynthia. So I'm going to keep tag here. There's 8. That's where we're stopping.
Right. Throw my blue dice then, please.
Throw your blue dice. Here we go. Oh, 5.
5.
To there.
Yes, I'm still a gambler. Off we go again.
8. Whoops. 1, 2, 3, 4, 5, 6, 7, 8. So Cynthia's had 5 and then 8. All right. Again.
Yeah, come on through. Yes, it must work. I must get the 3rd at some point.
Oh no.
10.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
I will stop now. That's a big enough score to stop at.
Sorry, it's 5, 8, and 10. Okay, so put both markers on there. 5, 8, and 10, 18, 23. So Cynthia is at 23. Right, Team Red. If you want me to stop, you're going to have to.
You're going to have to do better than that.
Sorry, Team Red. We go back to the start. So, back to the start. Cynthia.
7. Yes, move 1.
1, 2, 3, 4, 5, 6, 7.
You can see Caroline's using 2 counters so we know where I started in case I get a 1. So we only go back to there. Unless I get a double 1 like Caroline, then I have to go back to 0. But I'm definitely going to throw another go. So
you can also play it where you have to remember where you were. So there's memory involved. You don't have to play it. Where are you? You've got a 7.
Yeah.
Playing again?
Yes, please.
Oh, no, you're not.
Right.
So you're back to 23. So you don't go back to 0. You just go back to 23 because you were at 23 in the last game. You see how it's much.
I got 1 rather than double 1.
And you can play this without the board completely. You could until Tony invented this board. Until the board came along, we were always just playing with numbers like this, and that works great. It works really well. Okay, so it's going from double 1 to double 6. Oh, well, that I'm afraid there's a 1 there, so we don't make progress. Cynthia. Oh,
No, I don't.
You don't make
Okay.
progress either. Right, 8. Well, now we have to take a risk or else we'll never get there. So we've got 8.
Yes.
1, 2, 3, 4, 5, 6, 7, 8. Oh no. Oh, 1, 2, 3, 4, 5. We're not ahead, but I don't feel, no one's commented to
No.
stop or keep going, but I feel we had 8, 8, and 5. So we've got 21. And I'm saying we're stopping. Cynthia.
Yeah.
Oops, I put both markers on there, so that's why we're stopping.
Okay.
8. Wait. 2, 3, 4, 5, 6, 7, 8 there.
And again, please.
Oh. 1, 2, 3, 4, 5. So that was 8 and then 5.
Okay, I will stop there now, just in case. I'll be a bit more cautious this time, as you are on the board.
Finally. Okay, now. All right, guys.
I got to, oh, are we adding my 13 to 23?
Oh no, I don't want to do that. You got to check the person that's doing the recording as well.
Yeah.
Make sure they're doing their job. Thank you, Cynthia.
No problem.
Oh, 10. So 21 to 31. We've kind of got to risk it because Cynthia's ahead. 1, 2, 3, 4, 5, 6, 7, 8. For the first time in history,
Yes.
Team G10 is ahead of Cynthia. So I'll just write down, we're now at 39. I don't remember what we had, but we're now at 39.
Right.
Oh, we had,
Okay.
it was
Now,
10. It was 10 and 8. It was 10 and 8. Now we're at 39. Okay, blue. 5.
5, yes, please. And again, please.
Whoa. This could be good. Oh, it's not good.
8.
1, 2, 3, 4, 5, 6, 7, 8.
Okay, we're just going to 50, aren't we, this time?
We are going to 50, yeah, just for
yeah.
time, speed-wise.
Right, okay, I'll better stop then, I think.
Okay, so that was
49.
You're at 49. So ideally you are adding these up. So it was 8. So we got to 41. So that was 5 and 8 is 49. And yes. So the good thing about doing it this way, of course, is that this is for younger learners and inclusion and just for a fun activity, which involves probabilities with your class and making decisions and risk taking. So there is benefit to it. But if you want drill and practice, they need to be doing the answers. So okay, team G10. Ooh, 1, 2, 3, 4, 5, 6, and we've kind of got to go for it. If we score a double 1, we're just scuppered. Move that out of the way. So we had 1, 2, 3, 4, 5. We had 6, and now we've got 7, and we're going to go again. We're going again.
You haven't moved. Haven't moved to 7, have you?
Oh. 1, 2, 3, 4, 5, 6, 7. Oh, maybe we'll just stop.
You're coming back. This is
We're
interesting.
coming
You're
back.
coming back,
We're
but
coming
I'm going
back.
forward, aren't I?
You still got to get to
Yes,
50.
I've still got to get to 50.
Okay, so now we've got to 50, and now that's a bit complicated. We've got to 50, now we're going back again. So now we've gone, basically, we're just going to say we're at 48, but we're going backwards now. We're going to subtract from here on in. So this is a great incentive to get your learners to do subtraction. Right, Cynthia.
Yes, please. There we're going. 8, so yeah, so 4.
1, 2, 3, 4, 5, 6, 7, 8.
And again.
Whoa. Oh, so that was 8. Must write this down. So because it's a nice little thing having to work this out where we're going there, but we're basically on 43, and we're going to take minus 8. Take 43 minus 8. This is the second throw, isn't it?
Yes.
1, 2, 3, 4, 5, 6, 7, 8.
Which should be the 1, 2, 3, 4, 5. Yes.
So now we're at 35.
Yeah.
Well, done yet. So you're going? Stopping, going, stopping.
I've done 2 throws, haven't I? Let's try 3. I didn't at the beginning, my 3s didn't work, but
Oh
hey!
no, minus
That's
10.
good.
So that's going to bring us to 25.
Yeah.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That should be 25. Yes.
And I will stop there then.
Are you sure you can
Yes.
continue?
No, I'm stopping there.
Okay. All right, well, we better get a wiggle on here. 1, 2, 3, 4, 5. So that's 48 minus 5. This time I'll definitely do it every time. So we've known 43. And we've got to throw again, or else we'll. Right.
Oh.
So we go back to 48. So forget that. And Cynthia.
Yeah. No.
Oh.
Yeah. No,
Oh dear.
quick.
Right. 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's 48 minus 8. 40. And we've got to go again. That's not good. We're back to 48 again. Scratch that. All right, so we're going to just move this over, turn it round. So Cynthia is at 25 and team G10 is at 48.
And we're both coming back. So
We're both coming back.
Minus 8, yeah.
You sure you want to do that? You don't want to just give up and concede the game to us? 1, 2, 3, 4, 5, 6, 7, 8. So 48 minus 8, 17.
Come
That's
on.
it. You're done.
No,
You're done,
no, no,
finished?
no, no.
Oh.
I'm one world's back gambler. Lovely. 8 minus 8.
1, 2, 3, 4, 5, 6, 7, 8 minus 8. 9.
Oh, shall I? That was only 2 goes, isn't it? Yes, come on, third go. No!
That's all right. We don't mind. And here we go. Oh, 11. Oh, that's much better. So we'll go to 40 there and one more. That should be 11. So that's 48 minus 11. 37. Is that right?
Yes,
30. Yes. Yeah. Oh, here we go. 1, 2, 3, 4, 5, 6, 7. Yes. Okay. And we've got to go again, or else we'll never get there. Ooh. 1, 2, 3, 4, 5, 6, 7. So 37 minus 7 brings us to 30. And I need some help here. I've got deep dark, no sound at all. Oh dear. Oh, we managed it. Thank goodness for that. You were there. 1, 2, 3, 4, 5, 6, 7, 8. So that was 30 minus 8 takes us to 22. And I think I'm going to have to vote for us. I'm saying we stop there.
Okay.
Cynthia.
Yes. Yeah, good. 6, yes.
1, 2, 3, 4, 5, 6.
And again. That 9 had to be scrubbed off because that was a.
That's right. So you're at.
Yes, 17.
But
No,
you weren't at 17.
I was at 24. Where have you got 25? Did you not?
25. I must have.
Dear.
Oh, I was doing it as I went. I need to do a double line. Okay, I've got a double line there, so I know that's the place to go back to.
Yeah.
Okay, so 6, 1, 2, 3, 4, 5, 6, and that was from 25. That is correct. Okay, so 25 minus 6 is 19.
Yeah.
I take it you're going again.
Yes.
Oh no. 1, 2, 3, 4, 5, 6, 7, 8, 9. 19 minus 9 is 10.
Yeah, I will stop.
Again?
No, I will stop. Otherwise, this game will never come to an end.
Okay, so
thinking it would take a very long time to get to 100 and back.
Yes, I suppose so. You can play variations of it.
Yeah.
Depending how much time you've got. 1, 2, 3, 4, 5, 6, 7, 10, 11, 12. We're sitting on top of you right now.
Interesting.
So 22 minus 12 is 10. Wow. Double line under the 10 so that we know that's the point. Okay, let's see if we can get to the end here. Now you can play so you have to get to 1 and go back and forth, in which case the position that you start from is important. I think for today, because there's a chance that we're going to win, we're just going to say get back to start, you've won.
Yes, I think so.
We're going to win, team. Woo! And we
Yes!
did.
Oh,
We
no!
won after all that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But ideally, you would actually go back to 1 and then 10, 11, and you'd be there. And then you've got nice probability thing of what's the best position to be stuck in if you throw a 1 to actually hit exactly on 1. But we'll just there. You get, hopefully you get the idea. And this is your drill and practice and really getting familiar with your numbers, and this is your way of really making it a fun game. And we look forward to hearing how you use it and what give us your ideas, your on paper or on the board or variations of the board. Go for it. Over to you, Cynthia.
Yes, well, as I think Caroline's just said everything that
Oh, I'm
that I was
sorry.
going to say, but that is no problem. She can set up the next game, which is the target games. But yes, the one that we've just played, as she said, it's drill and practice certainly, but it's also really is experiencing probability with a vengeance, because you should ask or get your learners to analyze what is the probability when you throw 2 dice that you will get a 1, just 1, and what's the probability when you throw 2 dice that you'll get a double 1. So how likely is it to happen, and how will that influence how many times you throw? Now, I think most of the times when we just threw 2 dice, we were lucky enough and those 2 were fine, except sometimes we got a 1 on the very first throw. I mean, that's probability for you. But would you have a strategy? Would you think before you start, I'm always going to throw three times on the run, or are you just going to throw once? What sort of strategy? Will their strategy alter as you get closer? I think you probably heard Caroline say a few times, oh, we're behind, Cynthia's way ahead, therefore I think it's worth risking another throw. So that was her thoughts. But can you analyze the game and work out theoretically what's going to happen, or would you just use it as an experience for your learners that just because the probability of getting a 1 is whatever it is, it doesn't mean to say that after so many goes you're going to get a 1, because that's not how probability works. So that's a very useful exercise.
So the other thing is, yes, what you said, this is a low entry, high ceiling. You can do it, use theoretical probabilities and actually do the probability calculations to take it to another level.
Right, so we're
Okay.
going to go into target games now, Karen. So you need your spinner, but
I've got my 0 to 9 spinner.
yes. So
are we starting with spin high, spin low, or the other one?
We're doing the target. So we're targeting but notice the spinner this time is 0 to 9, and it's a different one. It's not the bingo spinner. The bingo spinner was 1 to 10. So it still has 10 possibilities, but this time, because we're using digits, we want to be able to use 0. And what we're doing is we're spinning, so we're back to more probability. But the twist on this is that we have a target of, we're aiming for 1,000 as a sum. So we're doing this, you can see what Caroline's showing you. This time we're adding, and we're adding 2 3-digit numbers, and we want to get as close to 1,000 as we can.
We just encourage everyone to play along with us and see. I'm not going to show you. I am going to place it, but I'm not going to show you what I'm doing. I'm going to make it. What do you think, Cynthia?
Yes. So you and I will both have our own private little grids, and so can the teachers as well.
So I'm going to draw another grid down here.
So we want 3 boxes on top of 3 boxes for our 2 3-digit numbers. And we're adding, so we want 4 boxes underneath to be the sum of these digits. Now we have to decide where we're going to place our digits according to what we get on the spinner. We're all going to get the same spinner, are we?
Yes, we're all going to use the same 6 digits.
Right.
And the objective is wherever we place them, that we want the sum to add up to 1,000. So we have to be aware of.
You have to be strategic. Oh, that was a bit fast.
Yeah, it it swells up the screw, so a nail might be better. Or
right, so we've got the digit 4. You need to decide where you're going to put your digit 4, everybody. Caroline and I will make the same decisions. Righty-ho. Again.
Okay.
8. Okay. 8. And we're just going for 1,000, aren't we? So that might colour
1,000. 1,000.
Yeah.
Place your digits carefully. 9.
9. Oh heavens. 9.
Yeah, that's about right. I could have said the same thing. 8.
Oh, what? You're getting too many high numbers here, Caroline. Way, way too high.
2.
That's better.
Is that what you wanted?
Yes, please.
Now I need a 5. I was going to say, considering I'm doing the spinning, I'd better not get a 5.
Yes. Okay, so now if you've got your numbers, add them up and see, we'll see. So add 9 up. 7. Okay.
Well, hopefully somebody did better than me.
Oh, no, not me, I'm afraid, no.
Okay, what's your answer, Cynthia?
I get 1,235.
Okay, bear in mind, of course, with your learners, they might, depending where they are in their journey, they might not realize that if you have a number that's under 1,000,
oh yes,
then you can that could be better. Like, and then the next thing you can do is look at these numbers, everyone analyze them together and see if you can work out which is the best way they could have been placed to get the number that's closest to 1,000.
I'll try and work out, so how close could we have got?
Yes. Not very.
No, 2, 7, 2, 7. You've got to have 4 and 8, and then I suppose 9 and 8. 9, 8, 17.
4, 9.
I think everyone. I can get 1,037. I don't know if you've got any better than that.
I'm aiming for under. We can't do under it. Can we do? No, we can't do under 8.2.
Well, we can get under, but that'll be too far under. We can have 200 and 400,
yes.
but the next, so we've got to have 200 and 700. 700 would be smaller, Caroline.
Is that? Oh yes, 700.
Instead of 800, 700.
Yes, 700. So that's an 8. No, yes, no,
Yes,
no,
4,
yes,
8.
8.
Yes.
Yeah, 8's
Yeah.
fine. So 12, 13. Is that the number? The numbers
Yes.
you have?
Yeah.
And then the other realization that they have, and it is a very genuine realization, is that they realize it doesn't actually matter whether the numbers are on top or the bottom.
Yes, because I wrote 249 and you've got 749. I wrote 249 and 788. So that's another thing to learn. So yes, so this emphasizes the place value. So our target was 1,000 using addition. We're going to have another game, are we, with multiplication?
Yes, let's go with multiplication. So this is what it's going to look like. We're going to do 3 on top, 1 and then 4.
3-digit number multiplied by a 1-digit number. And the target is, we're going for
5,000.
Yeah.
Target 5,000.
And the closest wins.
And the closest wins.
4, right. And we're making 5,000. Oh, goodness.
Making 5,000, yes.
Oops, I don't want it there. No, okay. Made my decision.
4. That's bad. That is bad.
I'm gambling now.
You can have a conversation with your learners before you start. and to actually do some calculations, but they can just play it randomly the first time. But I'm now going to work out, okay, what 5,000, 9 into 5,000, what is my target number to go 9 into 5,000? That's what I'm going to do. So 5.
Yeah. 9, 5. We want a 5 to turn up, really, don't we? Or another 4 would even be. But,
well, I definitely need, yeah, that wouldn't be too bad. But yeah, I'm deciding whether or not where to place my 9 is basically what I'm doing. I'm deciding, and then I'm like, okay, no, because no, yeah, putting it, I don't know. I've made a decision. Oh dear.
7, is it? Yeah. Yeah, yeah. Yours is the same as mine, I think, because those double 4s just scuppered us.
Yeah. So Cynthia and I have the same answer. Have I done it right, Cynthia?
Yes, yes,
Does
6,690.
anyone have a number closer to 5,000?
Or in fact, see what gets closer the other side, whether we undershoot, because that was the other thing we need to check, isn't it? What could we have put it in a better
Yep,
position?
let's give it a go. And this is the extra value of this lesson, is this procedure is to actually analyze it afterwards. So what are we going to do? We're going to 474 times 9.
Yeah.
Would that be the
If
optimum?
you do that one, and I'll do 494 times 7.
Okay.
You can analyze why is Caroline's better than mine. Caroline did 9 times 474, and I did 7 times 494. Now, I mean, Caroline's instinct that the 7 there would be better.
But it wasn't just instinct, because I did that calculation. I did not do 7 divided by it. If I had done 7 divided by 5,000 as well, 5,000 divided by 7 as well, I'd have had, yeah, I'd have had an even better idea. But it's because I did that I decided to put the 9 there and hope that I would get a yes.
But you see, the other thing is that we all should know how to estimate multiplying by 9, should we not?
Yeah, which
Because
is why
multiply by 9, you know, multiply by, say, it's roughly 10 times. So
yeah,
just a little bit less, 4,700. So you know the answer would be a little bit less than, well,
from 5,000, yeah,
500 less than 5,000. So
yeah.
you're getting very close to
yeah. And that's why I decided that I was going to do that sum, because I was estimating 9 times 500.
Yeah,
I knew it would be less than that, but yeah.
So
Okay.
lots of skills involved here, which we will think about later. The other variation on this is, so we've done an addition, we've done a multiplication. We can also do making the highest number or the lowest number. And,
okay.
And the other one is, or we can go closest to. Are we going to start off with a high one, I think?
So the highest number, the highest 4-digit number, is that what we're going for?
Yes. And at the moment, so Caroline and I, oh.
I'm not even going to hide where I'm going to put this one. No. You can all see where I'm going to put this one. I don't mind.
No. A variation of this game is that you can have your own spinners, can't you? So each person can have a separate spinner. If that might be more appropriate. It's up to you how you want to play it, but yes. So off we go, because if they're playing it in pairs and using the same, they might decide to do exactly the same as each other, which won't really help us. We want them to think about with their own number. So this is a 2, is it?
That's a 2.
Upside down, that's a 2, is it? Okay. We're going to the biggest number we can make, aren't we? Yes.
Yeah.
So there was some decision to be made there.
Oh,
I think that's isn't it?
I'm going to say the majority of it is on the 9, so we're going
unless
for 9.
You respin, unless you.
Yeah, I think that's a good case for respinning, because the end of the spinner wasn't clear.
No.
Okay, so this is where you take the risk, perhaps.
Yeah. So where is the good place?
Oh no!
By your answer, I guess we both took the same risk. Yes. Now, I've got exactly the same as Caroline, but I needn't have done. I could have put the 4 after the 9, but I was gambling on a number bigger than 4 because this is again probably look at the spinner. You know, this is a 4. Are you more likely for the next number that's spun? Is it more likely to be bigger than 4 or lower than 4? So you get your learners to think: is it higher or lower? Where are the? How many chances are there for getting a number bigger than 4? Well, you know, you can get 5, 6, 7, 8, and 9.
They
So
can
there's
actually
5
count
numbers.
them. Yeah.
So there's 5 numbers bigger than 4 on the spinner, whereas less than 4, we've only got 4 numbers. So there's a
3. Is it? Oh, 4. Yes, 0.
0, yeah. So there was a slightly higher chance of us getting a bigger number. So Caroline and I both gambled on the next number being higher. But you can ask your learners, why did you decide it would be higher? Why did you decide it would be lower? These are all good questions to to throw into the mix.
And then you can take those same numbers. You don't have to play again. You can take the same numbers and say, well, what is the smallest number you can make with those 4 digits?
Right, let's spin it again. Do we want to have your spin and my spin or not? Are we happy?
We can do that. All right, we can do that. So Team Cynthia, you write down Cynthia's numbers. Team Caroline, you write down my numbers. So Cynthia, Team Cynthia.
Right, what are we going to get? So this is our team. We've got a 1 team.
I'll record them.
We're going for lowest, don't we forget we're going lowest this time because we've done the highest.
I'm going to record. Whoops, you can't see that. So this is Team Cynthia. Put it. I'll just here. This is Cynthia. This is lowest. It is lowest. And there's the number. Okay. Are we going to go? We're now it's Team Caroline. I'll write down the number. And we are going for the lowest, so that's not bad.
Not bad. No.
Now, I think I'll just hide ours. There we go. Whoops. I'm not cheating, I promise. You'll see what I wrote when you reveal it. It's like, oh, the lowest number. Okay, here we go.
Cynthia. My spin. Yes, my spin. 8. I've got an 8, so that's just for Cynthia, nobody else. We're trying to make a small number.
Well, anybody that's on Team Cynthia, and if you've decided you're on Team Cynthia, they can. Or was it you against us?
No,
Cynthia against GTEN team. Oh, 7. We've got a 7. Okay, I know where I'm putting mine. Let's see if anybody else on our team can come up with a lower number. Right, Cynthia, 9.
Oh heavens, yeah.
That's not what you wanted.
This spinner is definitely weighted towards the big numbers. So this is Caroline.
Oh, that's not. Oh no!
Caroline's got the same.
No, that's bad. Cynthia. Oh no, I think that wasn't a proper spin. There we go. That's a proper spin. Oh, okay.
Is this me?
Yes, I think you wanted that, but maybe not right now.
Yes. Okay, and then one more spin for you.
We need a 0 too. We want a 1. That's not too bad. That's not too bad. As you can see, I actually wrote 0 there for some random reason at the beginning. Wishful thinking. Okay, so we got 1197. I got 1197. Cynthia, what did you get?
I got 1098.
Well, you certainly beat me.
Yes. And the next question is obviously to ask by how many. You know, that's another. So again, we're bringing in place value to start with, but then also basic arithmetic. What's the difference between 1098 and 1197? That could be, you know, you could say how much did you win by? Maybe you want to bring in some scoring system that you know, that you can say how many points difference there is between. It's up to you to use these games as you know, as best you see fit for your classes. Right, and then the last one. So we've done an add, we've done a multiply, we've done a highest, we've done a lowest. And the next one I want to show you is also a target at a specific number, but using decimals, because this is another extension. So that blob is a decimal point, or if you're in South Africa, you may put a curl on it and call it a decimal comma. There we go. So we've got 2 decimal places, and we're going for the target, what did we think about the target? 75, wasn't it? Just a,
Yes.
I mean, any of
Target
these targets you don't
75.
comma 00, yeah. But so now when your learners, you're now asking them to do some decimal subtract or estimating with decimals, or finding the actual difference from 75 by subtracting or adding decimals, whichever is appropriate.
I'm going to actually write it on here because that's not very clear where it is now. So we're targeting 75. I'm just going to write there. We're targeting 75.
Yeah.
Okay.
Yeah. So
right, here we go.
I need a, yes, so whoops, I needed another grid. And are
That's
we
a 7.
Are we going to use, oh heavens, are we using the same spinner now this time?
We can use, okay, we can do two, let's do two different ones. So Cynthia's got 7 and okay.
Well, why don't you put it in? So why don't you be first? So
no,
you
I haven't put it in.
Oh,
it's
okay.
fine.
Okay.
So you can have the 7, Cynthia.
That's very kind
we've
of
got
you.
you're welcome. 8, we're going to go with but with target 75, that's 8 isn't bad actually.
No.
And but Cynthia's going to be closer because she's got a 7 in the hundreds.
2, haven't I?
In the tens. You got a 2. Cynthia's
Yes,
got a
thank
2.
you.
7.
I've got another 7. Oh.
No, that's us. That's us. It's not yours.
No, that's what I said. You've got another.
Oh yeah, no, this is bad.
Oh, that could be good, I would have thought.
Yeah, but you've got a 7 in the tens. So right, that's yours,
And then
Cynthia.
me, I've got a 5. Well, we want 75. Oh, am I being lucky?
Okay.
You'll go.
0.
Ooh.
Okay, that's as good as it's going to get, having an 8 in the tens there. 6, Cynthia.
For me, right?
And ours is, I think that's a respin.
Yes.
5. Okay. So I think that is the closest that we could have, well, no, we could have gotten 75.08. Oh, that is awful. We could have had 75.08,08.
Yeah.
What did you have, Cynthia?
I made 75,62. I mean,
So
with mine, my closest would have been 75,26, wouldn't it? I got 75,62 because that's how that's as they came up, that's where I decided to put the numbers.
Yeah, and somebody could have, with those same digits, could have beaten Cynthia's team with 75,08.
Yeah.
So that's all the lovely discussions that you have.
Well, the two main things that stick out obviously is probability, how likely, we did discuss that, didn't we? If we've got a 4, how likely is the next number to be higher or lower than 4? Or any other number that you might, I mean, obvious one would be 2, if you've thrown a 2, then the next number is you get, if you put a 2 in a certain place, the next number is definitely more likely to be higher than lower, but it doesn't have to be because you've still got 2 chances of it being. So all these sorts of talking about using probability language when you're doing this. And the other big one is place value. Are you going to put this digit in the hundreds, the tens, or the units? The big takeaway from all of these games that we keep coming back to is that you are in charge of altering them and setting the level. So this is why we say you can set them for primary, intermediate level, lower secondary, upper secondary. You can set the level for your particular class. You've got multiplying a 3-digit by a 2-digit, or you can use division, or you can have addition of 3 separate 3-digit numbers. So you can make this as you wish. And there's a subtraction. That's even more of a challenge, I would think, for some of us. Target 3,000, but subtracting 2 4-digit numbers. So you are the creator here in your classroom. So you create the task that is most relevant for your learners that you've got at the day.
The next game we're going to play is, so the objective is to get from 0.00 to 0.66 And because of the nature of the game, this actually wraps around itself. So 0.01 is the same as 0.61. 0.00 is actually the same as 0.66, but because of the way we're playing the game, you do actually have to go across the board to get to it. You can't just say, I've won when you start. But apart from that, this and this point is one and the same. This and this point is the same. This and this point is the same. So when you're counting across, you're going to go, let's say you throw you decide to go across 5 from here, you'd go 1, 2, 3, 4, 5, and going upwards. So you're going from there, you go, let's say you're going to go 6, 1, so start there, 1, 2, 3, 4, 5, 6, and hey presto, you're actually in the same place where you started. So this game is giving you new visualization, which Cynthia will go over afterwards, or
Cynthia
we might
with
okay, so there's a lot in here. Strategy, probability, you've got the grid points, you've got the visualization, you've got the spatial awareness, axis references, vectors. There's so much in this game, and it's a fun game to play. So it's familiarization for your learners with concepts that, I don't know about you, but I've got learners that really, really struggle to identify a grid point, just that. And this game is played so that the x-axis is mentioned first. So every movement you do, the x-axis goes first. So you'll see it play now. We're ready, and we're ready. So this is Cynthia against Team GTEN. So you're all with me. We are, keep it consistent, we're red, Cynthia's blue, and I'm just going to throw. So Cynthia's got to decide whether she's going to play 1-2 or 2-1.
Okay, as it's my first go, I'll go 1-2. So 1 along and 2 up is what we're doing, is it? 1.
Yep. Yeah, we're just using the normal graph reference, axis reference. So X is first, Y is second. Right. Our turn, double six team, double, that's not a double six. We're going to go 1, 2, 3, 4, 5. So we're going to go 5, 1. So 5 across, 1 up. 4, 6 or 6, 4.
Oh dear, where am I now?
You've got there, or you can choose. Oh, by the way, you've got to get both of your markers here. So Cynthia can choose to move that one.
Oh, I hadn't spotted I've got
that one.
Of course.
Sorry, you couldn't see it. I was hiding it in case you forgot it was there.
Forgotten I'd got 2 counters.
And one of the things to bear in mind is, do you want both counters on the board at the same time? Or do you want to leave one while the other one gets to the target?
Yeah, understood. I I think I will move the one that's in play, as I've got a 6. So we'll go 6 first. So 6, if you swap them around, 6, 4.
1, 2, 3, 4, 5, 6. So
yeah, we discussed that earlier, didn't we? 6 just puts you back to wherever you, whichever way.
So I was counting 4. It, but next time I won't move it. So 1, 2, 3, 4. Cynthia is there. I could move her there, but for now it's the same. It's the same as there.
Yeah. Well, why don't you put me there? Because the way I try to visualize it is that we can only play on the dots rather than the pointies are actually move off, go away. I think the triangles to me say move.
Okay.
Look like more like an arrow than a triangle in my head. Yeah. But that's only me visualizing it.
Well, each one of us is going to visualize it differently. So
quite.
5 and 4. So I'm going to put both of mine into play. And I'm going to go 5, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. So we have choices there. Cynthia.
3, 4.
Which way do you want to play it?
Okay. Right, let's keep to the same one that's on 1, 2. We'll go as it is, 3 along and with that one. Yes, 3, 4.
So now you need a double 2 to hit the target. Oh, oh, oh. So we're going to go
Well done.
1 across and 2
Yeah.
up, 1, 1, 2, and we've hit the target.
You've got one there. Well done. Yeah.
Okay.
So my go, I want a 2, 2 or a 6, 6, don't I?
That's not a 2, 2, and it's not a 6, 6. Sorry about that, Cynthia.
No, I've got to make a decision. Right, I've fed up with the other one sitting there. Let's go 4, 2 with the one on 0.
4, 2 with the 1 on 0. 1, 2, 3, 4, 1, 2. Oh, sorry.
Yes, you've won. Well done, Caroline. Look at
Well,
that.
I could do it the wrong way round.
No, no,
Actually, can I do it the wrong way? I can't do it the wrong way
No,
round. Either
you're
way I
in.
do it. Well, we're going to go with that way. 1, 2, 3, 4, 5, and 1. And team GTEN, we won that one.
Excellent.
So it's a fun little game that you get a lot of visualization. I was struggling with some of it, and you also get well, it's mainly the grid reference, everything I mentioned before. Listen to the recording, you'll hear it again. If you have anything else to add while I set the next one up.
Well, the fact that you did suggest that it would be, or that it might be just as well to leave 1 on 0, 0, because you could win in one go by throwing a double 6. But so
which
yes,
I did last night when I played it.
When we practice, yes, so when we practiced it before, then certainly it is a possibility, and then you get there in one go, which is fine. The other thing to think of is to get your learners to think, what do I need to throw in order to get to 6, 6? What combinations do work? Can I get there in one throw from anywhere on the board? Right, because when I was playing it before, I kept getting stuck round on the axes and couldn't get. I just worked out you can't get to 6, 6 from every position on the board. So that's another thing. Are there places where you want to avoid? So all the strategies do come into play here by visualizing moving across a grid and getting an intuitive idea of what a vector is anyway, although it might not be in your school curriculum. You probably don't want to mention the word for some of your learners, but they are getting the idea that you can, when you move through a Cartesian grid, you move along an x-axis and then a y-axis in turn. The other thing, does it matter? Sometimes you end up back at 0, 0. It's if you jump onto someone, if you land on the same position as someone else, then you send that person back to 0, 0.
I had forgotten about that.
Yeah.
So thanks for pointing that out. That's a nice little
But
quirk
again,
added to the game.
Perhaps with younger learners, that won't be appropriate, but depending on whether you think they would be upset about that. But it's not basically necessarily a bad move because from 0, 0 you can make good progress. Again, there are various ways of playing this, but I use this practically every course that I give for different levels for different reasons. It is a very, very useful game that you can adapt to suit your curriculum and the learners you've got in front of you. So basically what you have is you have what looks like a triangle, but you've got ovals or circles at the vertices of your triangle. So there's 3 vertices, so we've got 3 ovals, and then in between each oval you've got a rectangular box. And the rules of the game are that you put some number or some expression in the ovals. You decide on some sort of mathematical operation, and the answer to that operation you put in the rectangular boxes that are between the ovals, between the vertices. Yeah.
So you can consider the vertices could be kind of, are they the rectangles to be kind of the equals?
Yeah. Yes.
So A plus C
Yes.
equals B.
Yeah. So
In
you
this case.
combine what's in A and C according to the operation you've chosen. So if you've chosen add, then you add A and C. If you've chosen for your operation multiply, then you multiply A and C. So A and C get worked on by some operation, and the answer you put in B.
We're not going to go, this says the winner is the first to get 10 points. We're not going to play it that way. We're just going to show you how to play the game.
Yes, and then some different variations, and you can play it as a game and decide your point system all to yourself, as long as you understand how the game works. And that's what we're, how the basic process works, and that's what we want to show you. So Caroline and I are going to do play some games. Caroline's going to do the first one that's there that you saw the bottom right. This was using addition. So you've got, well, first thing to say is that if you put all your numbers in the vertices, it would be relatively easy. So that would be a starting point to your, if you put some numbers in A, C, and E, then that's for the lower learner, the younger children, or the lowest, because all they would then be practicing is their adding up. We've taken this one as the next level up. This is just slightly more difficult because Caroline has to do some thinking. She's got one answer and two sets of numbers. So where are you going to start, Caroline?
I'm going to start by adding. And it's quite intriguing because these look like hard sums, but actually it's very beautiful because you've got ones and nines combined. So this is actually going to give me some number sense by doing this. So I've got 0. And then the next one is 10 plus the carried over. So I'm going to be playing with ones, and I'm going to end up with 11,110.
How did you hesitated there, Caroline, as to whether to put that one in or not, didn't you? That last
Yeah,
one.
I did, because I wasn't sure how I was making sure I'd counted the right amount.
What would you do to?
So what I would do is I would say 9,999 is very close to 10,000, and then we're close to what was that? No, yeah, that's it. To add 10,000 and add 1,111. But I've added 1 to get that, so now I need to take 1 away. Sorry, you can't see what I'm doing. I have to take 1 away, so now I've got, and that's actually a nice super simple way of doing it.
Yeah, using estimating, yeah. A number sense, as you say, idea of how big is the number. Was 1,110 big enough? Just having an idea of the size of numbers is a great skill.
You asked me about why I paused, because I was thinking, okay, I could see so many ones my eyes were going cross-eyed. So I was estimating, I was like rounding that to 1,000. Like, okay, I've got 10,000 and 1,000. So my answer is going to be more or less 10,000 plus 1,000. So it's going to be in the order of 11,000.
Excellent.
That's why I paused to make sure I had them right. I was in the right order there.
Which is important, All right, now where next?
Now, okay, so I'm going to do some subtraction, but this looks horrendous.
It does indeed.
Oh my goodness. Oh my word. Subtracting that. Okay. Here goes nothing.
And no calculators involved. So what are you
going? Oh, no, I wouldn't, especially with numbers like this. You really don't want to use calculators because they're such beautiful numbers, basically. I'm going to just rip things off and use the back of this. I'm not using paper because I wrote this on a scruffy side of something earlier. So I'm going to do.
We can't see what you're doing, Caroline. Can you?
Thank you. Thank you. Is that better?
No, we can't see the other bit. Move to the right. Yeah, there you go.
Right. Okay. Right. Do this on the edge here. Okay. Just these two now.
Yeah.
So 22,222 minus 10,000. Well, I'm not sure that I fancy that too much, but I could do it the old-fashioned way. Or I could say 22,222 minus 10,000. 2, 2, 2, 2, 1. but I've taken away one more than I needed to. So all I now need to do is add one, and I get this beautiful number. Done it wrong, done it wrong. Can't tell if I can add or add or subtract, one or the other. And that is the number that I put in there, and it's seeing some beauty of how numbers work together.
Excellent. Yeah.
And then the last one is super simple. Get the right order. So I know it's going to be about 13,000 because I'm going to add, it's going to be more than 13,000. So it's more than 1,000. I'm just going to go ahead and do this one. So I've got 4, 3, 3, 3. There's 3 of them. And then, wait a minute. I think I might have goofed up. 4, 3, 3, 3, and then 1.
2. No, you're right.
No, I'm not.
Right, you're right.
No, I'm not. No.
13.
All right, this just goes to show you really should write it out.
Oh yes, 1.
So 12,223 plus 1,111 got my place value going here. 4, 3, 3, 3, and there's no carryover. There is 13,000, and I knew it's going to be 13,000 because I knew it was going to be 12,000 plus 1,000.
Yes. That's me who's messed up on that one.
Okay.
I wanted a different pattern. Without
sorry about that. Sorry. Tony's written all this. I don't take any responsibility. Sorry, Tony, can you please give a different pattern for Cynthia? There's some wonderful resources on the AIMSSEC Facebook page, and that does include some amazing patterns, and on the Aiming High. Okay, what's the next, Cynthia?
Do you want to demonstrate how easy it is just to do one, make up your own?
I'm going to make one up.
If you make up your own, and this is what we want the teachers to be confident to doing. So just draw your basic ovals and rectangles.
The tip here, always do the rectangles first, because you will find, at least if I do it, if I just start with the ovals, I end up without enough space for the bottom rectangle. So I draw the rectangles first, make sure you have enough space for your ovals, and then just join them together. Super simple there. And then you can decide on what your operation is in the middle. And so just, if we're going to do addition, I'll do one addition and one multiplication, shall I?
Well, to make up multiplication together in a minute.
Oh, we'll do that together. That's fine.
Show how to make one up.
Doing addition, just keep it simple. You can, if you're going to create a puzzle with the kind of numbers you want them to be working with. So I'm going to do, I'm going to kind of work with the number 15. So I think this is kind of early years, but still I'm going to use 15 there, but then I want to maybe go a bit higher. So I'll go a bit more complicated, 21, and then I've got my answers. Super simple. 2, and you can make sure that your numbers stay within the comfort zone of your learners or stretch them. That's it. That's all you need to do to create the puzzle. Then you can present them, depending where they're at, you can present them with blanks on the rectangles, so they have to do the addition, or you can present them with a puzzle. You can mix and match like we did on this one. We were given this, and this, or you can give them just the contents of the rectangle, but you know that it works because you've created the puzzle first, and so you know that it works. So then you just give the answers, and then they've got to work out.
Brilliant. Yeah, and that's what we're going to do next, Caroline. We're going to do a multiplication where I'm going to give you the answers, and we've got to work backwards. But that was
addition. Yeah.
Yes, that's an addition one. And as Caroline has just showed you, we said you can do it with algebraic expressions. You know, it doesn't just have to be numbers. You just sort it out to the level of your learners and the class and the topic that you're delivering that day. So I've used it in many, but with many different situations. Right, Caroline, if you draw another quickie there, just draw it out.
Oops, do the rectangles first. Follow your own instructions, Caroline. Okay, and this is multiplication.
Yeah, and we're going to put in what would be B, put 16.
So A, B, C, D, E, and F. And you can do this one-to-many. You can do it with your whole class. You refer to it. You can do it over Zoom as well. I've done it a lot over Zoom. So B is, sorry?
16.
16.
D is 48. And what was it? F is 12.
Okay. All right, so what are my possibilities to get 12, assuming we're dealing with whole
numbers,
whole positive numbers.
Yeah, definitely.
So my possibilities for 12 are 1 and 12, 2 times 6, 3 times 4, and that's about it. Okay. Now 48, that might give me some clues. Okay. So it's either 1, 2, 3, 4, 6, or 12. But I need this number here to be higher. And I'm just wondering if I make that, no, that 12 times 4, it can't be that. It can't be 12 times 1, because then that would have to be 4, and that
I
wouldn't
like your
work.
thinking, and this is exactly it, strategic thinking, yes. Because we can't have 48 on the left-hand side, can we?
No. So what if I had, let's go the next lower number. What if that was 6? That would be 2. That would have to be 8. Well, what's 6 times 8?
48, yes, that's fine, yeah. Yes, well done, well got there. So that's the sort of thinking. What Caroline was using was factors. When it's multiplication as your operation, then you're looking for factors of these numbers. And as I said before, you can also use, if Caroline now can find the slide, you can then factorize not just numbers, but you can factorize algebraic expressions as well. So this is a very flexible nice little thing to play with your learners. So this is the screen. You can now see the different uses. I have used it in my study guides with addition of decimals. I've used it with integers. Both, this says here multiplication, but you can also use it with addition of integers, fractions, exponents, practicing highest common factors in writing them in that format. We were practicing factors. Caroline was looking for factors in this little mini little one that mini puzzle she just did, but you can use it as in factorized form. And the next one they've got on the bottom row is factorizing quadratics. Top right, you can mix up your fractions, decimal, and percentages. They don't all have to be the same operation, and you can put your own rules on as to how you want the answers to be given. And then the final one at the bottom right, you can actually use it with letters as well. If you're in some sort of a language mode, or you're doing something that you find that was appropriate, then you can put words where we're looking for common letters that are common to whatever's in the ovals to put in the rectangles. So that's the end of our time for games, I think, Caroline, isn't it?
Right. Yes, we just had that one more game, and that's a couple more games. So these involve familiarization with number. They're all in the book. This one's about visualizing shapes, 2D and 3D shapes in this particular case. Regular 3D shapes and regular 2D shapes. So this and many more in the book. And to summarize, I've put I'm going to do the 15 game. The 15 game, if you see here, we didn't actually play this, but you just saw it a minute ago with digits. This is with dots. This is so that the young learners can play it. And there's a lot of things you can do. A lot of these things we've been doing, you can do with dots so that younger learners can play it just by counting dots. Cynthia.
I think we have done most of the reflections as we've been going along, but
I've played check it with dots. I have played check it with dots. Just adding, with young learners, it works beautifully, and it introduces subtraction very nicely using dots with Check It.
No, I just want to emphasize really that if we think about what we said at the beginning, the spiral learning path, that these activities are not just for the very, very youngest, or not for any specific age or ability, because it depends totally on you as the teacher, the instructor, the person who is running the class at whatever level. Games are worth for keeping learners actively involved in the learning activities. Exactly, that's exactly, Nova, what we were saying at the beginning, because games and playing is what comes naturally, and what most learners have a positive experience. Not all, I mean, some people do if they've failed and had bad experiences with games, but most children enjoy playing games, and with giving them the right level of game to play, they will respond positively, and it can be a lovely way of getting them interested in maths, particularly in doing revision. That's one of the most obvious ways of using it, and the sort of basic drill and practice. I mean, it's much more fun to practice doing your multiplication using the target game format than it is sitting there with writing things in columns.
Absolutely. Get loads of drill and practice and loads of analyzing. Instead of just going, oh, well, what's 9 + 1? You're analyzing, well, should it be 9? Should it be 8? Should it be, you're doing lots of peripheral thinking rather than just doing a list of exercises.
And do take it with the older learners. Do ask them why. Is the game fair? How can you win? Why does it work? Why does this not work? Get some analysis done that will also challenge right the way through the school.
And with the analyzing the bingo game, and mostly the bingo game of these examples is, have you found all the possibilities? What are the best numbers to use? All that analysis is all building them up to being mathematical thinkers.
Yeah.
All right, so we've got all the links to all these resources, all these games on the Aiming High website. Click the link and it'll take you there. You've got the Aiming High learning packs. An Aiming High learning pack is a page on the Aiming High website, which has the PDF. It's got we've got some of them have videos. All these games, we will eventually have videos to go with them that accompany the book. And you've got the notes for teachers with key questions and connections to the curriculum, and inclusion guides, so that you've got your inclusion with your early entry. Lots of ideas for the lower attainers, plus things to stretch the higher attainers. And that's the link. We've got the Maths Toys YouTube channel. You've got the AIMSSEC Facebook page with every single day there's an activity for you to look through. You can just look through the whole. If you look through 450 days worth, you'll find something that will interest you. And you can also search the Aiming High website for topics. Thank you very much from me and Tony, who sends her best regards to everyone.
And me.
Oh, we've got Rashid said, this is a very nice aspect of learning mathematics. Thank you. Well, thank you, Rashid. Thank you very much. See you next time.
Right. Bye, everyone.
Thank you, Cynthia. Bye-bye.
Bye.
You can buy the book. The link is in the description, and you can download just the PDF, which costs less. And you can also, free, whether you buy the book or do the PDF, you can go to the Aiming High website through the link on the publisher's website and get all the resources that you need to play the game. You can print them out, draw them out, enjoy. There's some great games in here. There are 36 main games and lots of peripheral games. The games in the book, there's the traditional 5 in a line game that we've made into a numbers game that we're playing the video. There's some odds and numbers, odds and colours game for statistics. We have fraction wall games for fractions. There are games for fraction, here, frogs. This is logic, being systematic. This is a great game to help any age learner, because you can use 3 frogs, 2 frogs, or 10 frogs to make it as complicated as you like for different age learners. Just randomly flip to one other page, and we've got what we've done. We talked about the fractions. Here's one. Here is a game that is simple to play, and there's some very interesting connections that you can make. A lot of the games in this book have connections across, and that we cover all the topics in the math curriculum. Enjoy. Please buy the book.
This is a Global Teacher Empowerment Network video collaborating with AIMSSEC and the Aiming High website. Our mission is to benefit children in disadvantaged communities all over the world by empowering the teachers who teach them mathematics.